Hey kids, and welcome to Small Chalk Talk 1.3 with your host,
Me.
Okay, well, we're going to review equations all the way through here. We started equations with talking about how to deal with little teeny bitty, itty bitty one-step equations. For example, we started with this process where the goal is always to isolate the variable so that never changes. And when we're dealing with positive or negative constants on the same side with the variable, what we talked about was how we're just going to collect the constants onto the side that does not have the variable by making a zero sum. An example would be a problem such as this. In this problem, there is a positive constant. So what we're going to do is we're going to make zero out of that positive constant by doing the inverse operation of it. In order to maintain the balance, we're going to do that to both sides. And we're going to get x is equal to negative 7.7. Now we can go back in there and check this thing and put it back in. Use your handy dandy calculator to make sure that you get this correct. That is right. Again, so what we did was collect the constants onto the side that did not have the variable by making a zero sum. We can also do that with a problem that has a negative constant. Now, when I'm saying constant, I think you all know this by now, but it's this number. It's just the number. It's not the variable. So that is a negative constant. Though it's an addition, so to speak, addition problem, meaning you see an addition sign, you're going to make zero from the constant, no matter what. So in this case, it's a negative 9, so you're going to add 9 to make zero of it. You'll do that to that side, and you'll then get x is equal to, oh, Mr. Small almost botched that one, 21. Okay, negative 9 plus 21 equals 12. Indeed, when you take away 9 from 21, you get 12. So, reviewed that. We also then talked about if we are dealing with equations that are one step, that are multiplication or division. The other ones were addition, subtraction. What we're going to do is we're going to, still the same goal of isolate the variable, but we're going to get rid of the coefficient in the variable term by making 1. So we're going to get a multiplier of 1. An example would be this kind of problem. This is a multiplication problem. Those two things, so to speak, slammed right together mean multiplication. So in order to make 1, I'm going to divide by the coefficient, which is the number that is right there beside the variable. That's going to get me 1. Now what I mean by that is, and the reason we get 1 is anytime I do 1 times a number, I get that number itself. So that's why we want to make 1 there. Hold on one moment. I need to use my calculator for this, so negative 25.8. Oops, 25.8 divided by negative. It's very important to maintain those negatives with you, is g equals negative 6. Okay, but again, the idea of making 1 there is important. When it's a multiplication or a division problem, you're getting rid of the coefficient by making 1. Another quick example, if we do a division problem here, what we want to do is, technically, I'll just do this up here, the coefficient really is 1/8 times x, so the coefficient's 1/8, because anytime you divide a number by that, it's the same thing as multiplying that, whatever the number is here, it's the same thing as multiplying by its reciprocal, or its, well, not really, it's in this case 1/8. So, but without getting too confusing, what I can do here is just multiply by 8. And what that does is, this does 8 over 1. If we're multiplying that, that's really what we're doing mathematically. So this makes 1. 1 times x gives me x, and then x over here equals 48. So again, the idea, we've reviewed the one step there, isolate the variable. For addition, subtraction, were negative, positive constants. We collected the constants onto the side that did not have the variable. For multiplication, division, we got rid of the coefficient by making 1. Okay, so you see those, a little review. Now, we also did multi-step equations. Oh boy. That was a little bit of a hiccup for some of us. Okay, in that scenario, we learned how to combine like terms. We also learned about the distributive property. Okay, so let's just review what we learned for that. We learned that that was a combination. So when we did multi-step equations, we did the two processes that we did from one step in order to do the two-step. There was maybe a little step or so added there. It's not called two-step really because you may have to distribute or you may have to combine like terms. Again, the goal is still to isolate that variable. An example. Here, this kind of equation, what we need to do in order to start this is we're going to have to do several steps. So I'm going to rewrite this. And knowing what I know, I see parentheses and my brain goes, oh man. First of all, that means distribute. I know that. All right. Parentheses, distribute. Parentheses means multiplication. I know you couldn't see that clap real well, but or that sign or whatever, but here we go. So we distribute in the negative 3. That means negative 3 times x. We also do negative 3 times 2. We get negative 3x minus 6. That is all then done with. Plus 5x equals negative 9. Now, not only that, we must, so we just did the dp, distributive property. Now we must combine like terms. We only do that on the same side. Side meaning that there's two sides separated by an equal sign that are balanced. So I always try to circle my like terms. These are like because there is a variable here and a variable here. This is a constant, thus we cannot add it to these variable terms. So what I'm going to do is negative 3 plus 5 is really the math I'm doing. I'm just dealing with the coefficients. That ends up being 2x minus 6 equals negative 9. If I add 6 here and I add 6, I'm going to get 2x equals, now this here, two people are getting confused with this. This math is negative 9 plus 6. Type that in the calculator if you need to, but if not, you just know that you're going from a negative 9 on the number line, adding 6 to it, you're going to get negative 3. You divide by 2. You divide by 2. X gives you negative 1/2. I could go back and check that to make sure I'm right. I would go back and check that if I were you. It's right. Trust me. Okay. Whew. Okay, so we reviewed one-step equations where we had two processes that were separate, and then we talked about multi-step equations where we combine the two processes to collect the constants and to get rid of the coefficient of the variable term. That was where when we did this problem, if we go back, we collected constants here, yoink, yoink, and then we made 0, we also got rid of the coefficient by making 1 here. So we've now reviewed fully both one step and mini-step equations. Now we're going to the new and final one where we are going to do equations with variables on both sides. For example, one like this, okay? 3x minus 1 equals 9x plus 2. Now all we're doing is we're collecting the variables to the same side by making 0. We're collecting the constants to the same side by making 0. We're getting rid of the coefficient of the variable term by making 1. That will end up getting us our solution and our variable isolated. So let's do this problem. First process or step, so to speak, is to collect the variables to the same side by making 0. All right, so now we can't just leave one variable. Yeah, there's two. There's one on one side, or there's one on each side, I should say. So what we have to do here is we have to collect the variables on the same side by making 0. I'm going to deal, it doesn't matter which way you do this really, so you could take away 9x, both of these are positive, or you could take away 3x. I'm going to choose to take away 3x, again, because in this case this is a positive, so to make 0, I would take it away. I will do that here as well. Then I will rewrite what I have. Don't forget this negative. This becomes negative 1 equals 6x plus 2. Now, the one thing about the steps that you have to know is you can never leave a side as 0. Okay, that wrecks the balance. So if you were trying to balance this, if you put 0 on that side, it would tumble all over. So we actually have to take the constants now, when we're collecting them, to the side opposite of the variable. The same thing we've been doing the whole time. So in this case, positive 2 make 0, negative 2. I end up having negative 1 minus 2, which gives me negative 3, is equal to 6x. And lastly now, I get rid of the coefficient by making 1. Divide by the same number makes 1, and I end up getting negative 1/2, or some of you are fond to already do this, that's fine, either one is the same. Negative 1/2 or negative 0.5 equals x. So that is as simple as it is to solve a very multi-step with variables on both sides. You collect the variables on the same side by making 0, collect the constants to the same side, meaning the same side that they are going to be on. So constants are now on one side, variables are now on the other side, or opposite side of the constants. They're on different sides. Then you get rid of the coefficient of the variable term by making 1, and you have solved your equation, and you are a mathematician, or as I like to say, a math magician. Bye.